So Paul was the editor of the link spec in IB and the Rocky spec for RDMA over Ethernet. He's done a lot of work on using OpenFabric's interfaces for wide area networking. That's something that not a lot of people do, right? Lyndon is one of the people that does, right? He's now at Cray and as an architect. And you'll notice there are a number of people from Cray here this year, which is a good change for us. And Paul's got to focus on what are we going to do next, right? And that's the primary topic of this workshop. So Paul, off you go.
Good morning. So true confessions time. I just spent the past 4.5 days in Orlando shepherding a group of 90 high school choir students. I think on the whole I'd rather be here. It was a lot of fun, but that's a lot of work as well. I also learned in the process that travel from Orlando can be highly weather dependent, so that's my lame excuse. What's yours? So if you find me today and you talk to me and my eyes glaze over, or I forget my name or your name or the question you asked, that's why. Okay, this is really about, I gave it this sort of highfalutin title, Evolving Open Fabric Software, a tops-down approach. Sounds big, you know. But the real purpose here is to try to put some structure, as Jim said this morning, try to put some structure and framework around the conference this year. The idea here is that we want to maximize, to be quite candid, very selfishly, we want to maximize the value that the Open Fabrics Alliance gets out of the workshop. So what I'm going to try to do is to kind of frame the workshop for us and give us some things to chew on, so you're not just listening to a series of presentations one after the other. I'm going to try to put some ideas and questions in your brain that you can use to measure each session that you listen to over the next 2.5 days or so. And then we'll reconvene on Wednesday and see if we can put together what we heard into some sort of a reasonable story. So I have this idea, technology is a little bit like a shark. You know, sharks are always swimming. If a shark stops swimming, it dies. Technology is the same way. The Open Fabrics Alliance has been around since, when were we formed? 2004. And the IB specification goes back even further than that. Not to say that either of those organizations have stood still, nor are we in any danger of dying anytime soon. But at the same time, if we don't keep moving, someone is going to eat our lunch for us, sooner or later. So this session really is just about how to keep the state of the art in I/O moving forward. That's what we're going to try to do. And the purpose of this whole workshop is to try to map out a method for doing that. And I want to say that that is not limited to what we as Open Fabrics can do. It's also, you'll see in a minute, it's also a question of what we can do with our partners, specifically those who maintain the specifications on which the Open Fabrics software is built. So that's what this session is about. It's going to be completely different. This is unlike any other session that you'll ever see, because I'm not going to tell you anything you don't already know. Hopefully the other speakers will have things to say that will be of real interest to you. That is not the case in this session. So there's really going to be two parts. Jim mentioned this earlier. There's this one this morning. I'll try to frame the question. And then on Wednesday, we're going to come back and gather together as a room and see if we can answer some questions. And I'm trying to put a framework in place that let us capture the answers to those questions as they emerge. The outcome, ideally, will be some guidance or some recommendations or some suggestions, both to us as developers and to the standards bodies on whom we depend for our livelihood. So every session being presented this year is relevant to this key question. This really is the theme of the workshop. It's workshop planning started in, I don't remember, October, November, or December, something like that. But the theme really was, figure out how do you keep the state of the art in I/O moving forward. That's really the theme of this whole workshop. So your challenge here, it's a challenge to you in the audience. Sorry, no sitting there snoozing. It's time to pay attention and get involved. Is to really listen carefully to each of the sessions and engage in helping us answer this question and moving us collectively forward. So again, we're going to reconvene on Wednesday and see what came out of it, either good, bad, or indifferent. So this whole business of change and sharks and, what's change all about, I just jotted down here a few things that occurred to me. It's obvious that things are changing in the world. That's the nature of the world. Anyone in this room could have come up with this same list, probably in half the time it took me to do it, since my brains work slow. But clearly the scale of HPC systems is increasing. So we had a whole series of sessions in the last workshop or two over exascale computing, for example. So if you don't believe that the scale of HPC systems is exploding, well, pay attention. There are new compute models that are emerging. We all know this. So heterogeneous computing, GPGPUs, in conjunction with standard x86 processors. We're seeing the emergence or the explosion of what was predicted for a number of years, no surprise to anyone, which is a new, many or multi-core processors. And that's going to have something to do with how I/O works, whether we like it or not. There's this never-ending discussion about programming models, message passing versus shared memory. These are things about which I am not an expert, although I'm going to say a bunch of things today that are going to make me sound like the expert that I am not. Please don't believe that I am an expert in those areas. And there's basic technology, changes in basic technology. The one that's sort of stuck in the front of my brain right now is this emergence of solid-state memory. But there's lots of other examples of where technology is moving forward. So there's a lot of change going on here. But it's actually worse than that. There's actually changes in the way that people use computing systems in general. So, for example, we've seen the recent emergence over the past several years of big data. To those of us in the room, all of the people in this room have been paying attention for a while, and you know this, but I'm just trying to put it in front of us. So really, it's about analyzing, this avalanche of data that's emerging. That gave rise to this notion of big data. Another thing that emerged was this notion of the cloud, this biggest buzzword of the world these days, the cloud. And that's really a reflection of the fact that people, both scientists and users of large systems and home consumers, really are trying to store and access their data in new ways. It's no longer so much the case that you walk around with your laptop with its integrated disk drive and that's where all your stuff is. Where your stuff is may not be in your laptop anymore. And the other sort of large mega trend that I can see anyway is larger and complex problems are emerging. This really affects the people in the HPC community, most of the people in this room that you serve. And what's driving that is sort of a new kind of requirement for, or new types of collaboration. So these giant science experiments that produce, terabytes or petabytes of data, and you can't ship that data around, and yet at the same time, you want a team, an expanded team of people to be able to access and cooperate and collaborate on analyzing that data. So this is something else I think that's going on, is this sort of larger, complex problems, leading to this question about what do we do about data access over long distances. So this is sort of some of the, high level, what I see is change you can believe in kind of things. These are happening, like it or not. The question is, what are we in the Open Fabrics Alliance going to do about it? Or, put more positively, how can we take advantage of these things in order to improve the value of Open Fabric software going forward? So clearly there is change afoot, and we've sort of grouped them together into what I would call three large buckets. The first being the scalability question, most commonly typified by how do you do exascale computing, but it's much larger than just exascale computing in HPC. You see scalability pop up all over the place, particularly as it relates to I/O. The second is the way the computer systems are built. So this is a little bit about how you integrate existing technologies and new technologies, multi-core and heterogeneous computing and so forth, to build new computer systems. And the I/O infrastructure beneath them better be responsive to the way systems are going to be built now and in the near future. And the third is the way that users interact with each other. So that was the collaboration thing I was just talking about. If you think about it for a second, all three of these things, and there are more, this is just my particular way of categorizing them, they really impact the way that we look at and implement I/O. So to the extent that Open Fabrics Alliance is the premier provider of I/O software, we probably owe it to ourselves to be responsive to these sort of trends that are beneath our feet. So what I've done is, with Jim Ryan's help, this was his bright idea because I'm not smart enough to think in simple terms of three-column charts, which is exactly the way to do this. And, I struggled with this for a week or two until Jim said, well, why don't you just put a three-column chart? I said, well, that's easy. That makes a lot of sense. This is the chart that we're going to try to keep in front of our brains for the next 2.5 days of the workshop. And come back on Wednesday and see if we can fill it in. So on the left-hand side are what I would call sort of the broad challenges that are in front of us, the things we just talked about, scalability being one, the emergence of technology, what that means for computer systems and how they're built, and what that implies for the I/O architecture underneath them is the second, and the third being the way that people use these computer systems and what that means or implies for the I/O infrastructure beneath it. So the middle column is the one that we're going to have to fill out, the ask, so to speak. What are we asking anyone or ourselves to do about any of these things? So it all boils down to what changes do we need to make in the area of I/O to accommodate the fact that these challenges are in front of us. For example, down on usage models, how do changing usage models impact I/O requirements? It's a question that we're going to want to ask. And in response, we're going to want to ask somebody to do something about it. That somebody could be us, or it could be a standards body. For example, we might want to take this back to the InfiniBand Trade Association and say, hey, as providers of I/O software, this is what we're hearing, and this is what may need to happen in the network beneath us to make these things work. Michael's probably quaking in his shoes over there. So that's really what we're doing. Again, the question is figure out how to keep the state-of-the-art in I/O moving forward. And our challenge for the next couple days is going to be to fill in this table. So if you could take just a minute and drink this thing in and try to keep it in front of your brains over the next couple days, that would be greatly appreciated. All right, so to fill in this table, Open Fabric software, it uniquely fills a vital role for I/O services, especially in key computing environments. And I put that in because, OFA sort of emerged with a focus on high-performance computing systems. It's expanded way beyond that, as it should. But anyway, it is sort of key to, lots of what's going on in computing and I/O in particular. And sometimes things beneath us change, and I sort of outlined a few of those changes and maybe some ways to group them together. And there's lots more changes. By no means was that an exhaustive list. And all this means that the Open Fabric software is really going to need to evolve as well. And the pace of evolution may need to accelerate. We've done a great job over the years of maintaining and grooming and growing what we have, but I think the pace of change is about to grow. So foundations of OFS, I think it's unarguable that Open Fabric software as we know it today is built on top of RDMA. Not exclusively, but mostly. And I say not exclusively because we've seen the emergence in the past several years within the context of Open Fabric's Alliance or Open Fabric software of some upper layer protocols that don't necessarily talk directly to the provider layer. Actually, I've shown this picture wrong to make that point. Anyway, applications are always either coded to the Verbs API or they rely on a ULP, an upper layer protocol, or in the case of, let's say, PSM, they're coded directly to the hardware layer. So the evolution of Open Fabric software is really going to mean evolving the entire network infrastructure that underlies it. And I'll take just a second and talk about that because we're going to use this picture a lot. No red light, huh?
There's another one, the green one up there. Oh, it's in the clicker.
Oh, this little button?
Yep. There you
No green light, huh? So when I talk about the network, I got it. Thanks, Rupert. When I talk about the network infrastructure, I'm really talking about this part of it here. And I'll talk in the next slide a little bit more about what that means. But this word network infrastructure, we always struggle with what's the right word to use to describe what we in Open Fabric software do. Is it a network? Is it an interconnect? Is it an I/O stack? I don't know. Anyway, I'm just going to generally use the expression network infrastructure to dance around that question of exactly what we're talking about. But the key message here is that the problem isn't really solely about Open Fabric software. It's not solely an OFA problem. It's always also going to involve the underlying network, whoever the provider of that network is, whether it's Rocky or whether it's Ethernet or whether it's InfiniBand. It's a partnership. It's going to involve more than just us in this room. As far as that goes, the relationship of the Open Fabrics Alliance to the underlying network infrastructure, it's worth just a minute to make a point that's hopefully clear to everybody, but just to put it in front of our brains, is that Open Fabric software is the implementation of an I/O stack. And the behavior of that stack of Open Fabric software is really driven by the definition of the verbs. So let me make a point about the difference between the verb specification as contained in the InfiniBand spec and the verbs implementation as captured in the verbs API. So the verbs specification describes the behavior, and that behavior is what is implemented by all of you in this room as Open Fabric software. So there's a specification that defines the underlying network. We began the Open Fabrics Alliance with the InfiniBand specification. Since then, we've expanded to include Rocky and iWarp, and probably a few others as time goes by. And then there's this implementation of the specification provided by the Open Fabrics Alliance. So that was sort of my point about why it's going to take more than just OFA to move this thing forward. We're also going to depend on the standards bodies who define the specification and the providers of those networks beneath us. One point about roadmaps, this is a particular sense of frustration for me. In the InfiniBand Trade Association, we talk about the roadmap all the time, and that's a good and right and just conversation to have. We need to continuously be advancing the roadmap to the extent that consumption demands improved bandwidth. But it's really more than just the bandwidth issue. We really can't just rest on our laurels and saying we've got a roadmap that goes upwards and to the right. There's a lot more than that. The whole notion of RDMA in the first place, and I would venture to say Open Fabric software in the second place, is really conditioned on this idea that it's about communications between applications. That's what we're doing. It's not about how fast we can shoot bits across the wire. It's how well and how smoothly can one application communicate with another. So although it's important that we keep amping up the signaling rate because scalability and all the changes we talked about before are going to demand it, that's all important, but it's not sufficient and it's not likely to solve the problem. So there may be some other things that we need to be doing. So some of the challenges that lie ahead of us right now, I think it's safe to say, or maybe not, that InfiniBand today is probably the most scalable standards-based I/O solution in the world today. It has been for a long time. It was predicated on the notion of scalability to begin with. And yet at the same time, we're stuck with this notion of exascale systems in front of us. So we may be reaching the limits of our scalability roadmap in terms of InfiniBand and hence in terms of the Open Fabrics Alliance. So that's a challenge we're going to need to deal with. The second is, the second is technology itself. And I already talked about some areas where technology is galloping forward, and we're going to need to deal with those challenges as well. And the third is that people are using their computer systems in new and creative ways. They want to collaborate. They want to do different things with their systems than they've done before. And we need to deal with that as well. So clearly, in the past 15 years since the InfiniBand architecture was created, and in the ensuing 10 or 12 years since, or 8 or 10 years since Open Fabrics Alliance was formed, the ground has changed beneath us, and we need to move to stay on top of that ground. So the obvious question is, how do we move forward from there? Well, I guess the answer is sort of self-evident in the way the question is asked. We should take a look at raw scalability. We should take a look at understanding emerging technologies and how they impact the network and the I/O infrastructure built on top of that network. And we should look most particularly at the classes of applications, both those supported by OFS today and those that may be supported by OFS in the future. And we should get a sense for what that means from an I/O perspective. And if you look at the agenda, the workshop agenda, you'll discover that that's exactly how the workshop is organized this year. There's a whole set of sessions devoted to discussions about scalability. How do we scale connection management, for example? How do we scale the number of queue pairs? How do we scale the address space? Those are all subjects that are coming up in sessions later during the workshop. There are also sessions about the way people build and use systems today. So there's a series of sessions on HPC and how HPC systems go today. There's a PGAS panel coming up later, for example. There's a session about, or several sessions about how computing is used in the enterprise and what the intersection might be with Open Fabrics Alliance software there. And then there's a whole bunch of sessions about technology. So we're going to talk some about, for example, non-volatile memories and what the interfaces for those might be. So that's exactly how the workshop was organized, to really help us get our arms around these sort of three questions. Let me just do a brief at what I think is sort of amusing history of the Open Fabrics Alliance, pretty simplified into 3 slides. I think it's probably safe to say that the Open Fabrics Alliance did emerge as a way to keep the nation at the time InfiniBand industry from fracturing. So, as vendors, we were all off building our own versions of software stacks to build on top of InfiniBand, and it became pretty clear very quickly that if the whole thing was going to avoid fracturing into armed camps, we really needed to do this collectively as an alliance. And that led to the formation of the Open Fabrics Alliance. And the Open Fabrics Alliance created this feat of magic of coalescing the InfiniBand industry, as it were, by providing a common open source verbs API. And again, the specifications don't define an API, you define the API. And that's what the Open Fabrics Alliance did. It created a single common verbs API. So I think it's fair to say that verbs are really the heart of OFS, at least as we know it today. And one of the questions that I think we're going to need to be asking is, what is the role of verbs going forward? Does it continue to hold the same central role that it does today? My answer is yes, but we'll see what people in the room have to say about that going forward. I just wanted to offer the opportunity to think outside that box. So that was where we began. Over time, we've done things like added new underlying networks. So iWarp followed InfiniBand very, very quickly. And in the past couple of years, we've added Rocky to that. But the basics haven't really changed. It's still about the verbs API. Both Rocky and iWarp are to some extent compliant with the same verbs interface and function with the same verbs API. I'm being fast and loose with the facts. You all know that. That's fine. For our purposes here, for the conceptual point of view, we've really just added some new networks to an existing infrastructure. And along the way, a series of what I would call interface definitions have been crafted over time. I think we may have started with this hopeful notion that all applications in the universe would be rewritten to the verbs API and life would be beautiful. That was unrealistic, and I think everyone knew it was unrealistic. And the way of dealing with that was the addition of these upper layer protocols, of which there's a pretty good set that exists today. So this is the familiar architecture we all know today. There's an application layer at the top, which is outside of our scope. There's the upper layer protocols, the provider layer, and the hardware layer. So we got all that today. But the question for me is this really a forest for the trees view of I/O? So 2 things that always strike me right between the eyes whenever I look at the canonical Open Fabrics architecture picture are, it's dominated by the low-level details of the network. It's really all about the very low-level details. What's going on in connection management and what UOP is accessing what verb at what layer and that kind of thing. And the other thing is it tends to be a bottoms-up view, which is entirely natural when you consider that it all merged from the InfiniBand architecture, which is all the way at the bottom of the stack. And we sort of gave short shrift to that little dotted box at the top called applications. Not completely short shrift, but I think it's probably okay to say that we have really grown this whole Open Fabric software thing from the bottom up. But if you really think about it, the way that computer systems are used, they're really driven by applications. So my suggestion here is we start thinking from the top down. And I know everyone in this room does this. This is one of those entirely obvious statements. I haven't said anything remarkable, but it may be one of those things that, oh, that's an interesting thought. Let's do that. So maybe we can get together and start thinking in those terms. But if you think about it, the application layer's I/O requirements actually specify or drive the requirements for the interface that the application is going to use to access I/O services or resources. And the definition of that interface, in turn, drives what the characteristics of the underlying network really ought to be. So it really does, at least in my mind, make sense to start by looking at the applications of interest, beginning with the ones that we service today, and asking ourselves, what's beyond that? So I'm going to suggest that we start taking sort of a tops-down view to Open Fabric software My goal in life, if I'm successful at this, is to diminish the reliance on the traditional OpenStack software canonical diagram we just looked at, and sort of raise our focus up a little bit and start thinking at that top layer and then working our way down through the layers from there. So this whole thing, tends to recommend a top-down look. If the goal really is 5 minutes, well, I'm going to have to hustle. No, I got till 9:30. I got a lot of time. And I'll use it all, too. So if the goal is to improve support for applications of interest, which really is what we're doing here, we measure our success by how well we support applications that depend on Open Fabric software. So let's start that, put our money where our mouths are by looking at the application layer. That's tiny little letters and no one can read it, which is part of the problem. So let me blow it up a little bit. This is what's across the top of the Open Fabric software canonical stack diagram today. There's a little box about IP applications and sockets-based applications, which is support for various, types of legacy applications. We all know that. So, IP over IB falls in this category, and other ULPs we're familiar with. There's a set of applications about distributed computing, in particular via message passing using various forms of MPIs. There's a section about block-based storage, or network-attached block storage, so SRP, for example, or ISER. There's a section which is not, I don't think, all that active these days, but may become more active soon, but about clustered database accesses, so RDS, for example, emerged from that. And then there's finally a section about, or a class of applications, if I could be so bold, about network-attached file or object storage. So Lustre falls in that category, and NFS RDMA. This is just the way that we've sort of grouped together applications and put them on the canonical, Open Fabrics Alliance architecture diagram. So let me suggest a little bit different way of looking at that, and maybe bucketizing things a little bit differently or giving them a little bit more generic names to try to sort of broaden our thinking about the applications that we want to support going forward. So it's the same set of classes of applications that were on the original page, just organized a little bit differently. So there's a legacy applications bucket. There's a data analysis bucket. So I've expanded it beyond just clustered databases, and I'm calling it now data analysis. So these are all the sorts of applications that have to do with analyzing large amounts of data, or small amounts of data. There's a data storage and a data access bucket, and you'll see why I've chosen to rename that one in just a minute. But that includes things having to do with file systems or block storage. And then there's a distributed computing bucket, which today is populated or inhabited by message passing or MPI-based applications. So let's talk about what we might want to do or can do in the name of avoiding being dead sharks to broaden the categories of applications that we want to support. So that's this picture right here. Let's start by looking at data analysis. So in the data analysis category right now, we're doing a really good job with being able to manage, say, structured data. Everyone knows about structured data. Traditional databases are all built to work on structured data, but what we've seen happening is people are really trying to extract value out of massive amounts of unstructured data. So that's what Hadoop, for example, is all about. So the question that I think we ought to be asking ourselves is, from the perspective of, let's say, unstructured data, what are the I/O requirements that are implied by wanting to manage massive amounts of data in a Hadoop-like environment? And Hadoop's only one, one option. There's lots of them out there, but it's the one on the tip of everyone's tongue these days. So what are the I/O requirements to support tools for accessing and analyzing both structured and unstructured data? So this is an area where possibly the Open Fabrics Alliance might want to think about moving forward. Are there things that we want to do in terms of ULPs that would support that class of applications to better support both structured data and unstructured data? So it's all about broadening what we're already doing to make it more all-encompassing. So the next one is, let's take a quick look here at data storage and data access, and I promised I'd talk about why I broke it down that way. And I did it because distributed storage really means there's a shift in how data is accessed. So I talked a minute ago about the cloud And what the cloud really did is it took data from out of people's direct control and it put it somewhere else. So this whole notion of distributed storage emerges, and the question is, well, what does that imply in terms of the I/O requirements? What do we need to do in terms of I/O support to be able to support this notion of distributed data? And this is more than just Amazon Cloud, for example. Researchers have this problem all the time. So storage at a distance, because distributed teams of researchers, they demand this ability to collaborate on large amounts of data. In fact, those data sets are getting so large that it's no longer practical or even realistic to replicate that data set, across the globe, so that your team in San Francisco and some other team in Chicago and some other team in France can look at the data and work on it together. They need to be able to collaborate on the data, which is now too large to move around the globe in any practical way. So are there applications where we really want to be able to share access to data to enable collaboration amongst teams? So the same question is going to get asked here. What are the I/O requirements to support data storage and data access? So it's more than just storage. It used to be just about storage, but now it's really about storage and access. And by storage, again, I mean both block storage, but more than that, I mean about file and object storage as well. All right, so those are two quick examples, two areas. We looked at data analysis and a little bit about data storage and data access. And you remember my three broad challenges were broken down in terms of scalability, technology, and how it's used to to build computer systems, and usages. And what we've been talking about here is, this is what I mean by usages. How are people using their computer systems today? So fundamentally, I/O really has to support the way that people interact with their data and with each other. That's the collaboration part of it. And the question I think that I would like to put in front of us as an alliance is, what can we do in terms of I/O to better support the way that people really want to use their data going forward? I don't have any answers. I'm just asking questions. I'm great at asking questions, terrible at answering them. So continuing on, broadening support, the distributed computing category is sort of an interesting one. So we've got today, a broad range of MPI applications. There's a number of them out there. And we also have other ways of doing MPI that do not take advantage of, say, the verbs API. For example, PSM and MXM address this. But the question is, can we improve the scalability of programming models that are based on message passing, like MPI? Are the things that we can or should be doing? So you'll see in a minute here that I'm beginning to move into the question of scalability. So we've talked some about usages, how people use their computers and their data. Now we're moving a little bit into the question of scalability. So message passing has a sort of inherent scalability problem associated with it, because in a large system there's tons of instances, and those instances all need to exchange messages with each other. I am no MPI expert, so if I say things that sound silly and naive, it's because I'm silly and naive. But it does imply a large number of parallel connections, and they're essentially one-to-one connections. Yes, it's true that there is unreliable datagram. It's true that there are other methods to pass messages back and forth. But fundamentally, when you think about MPI built on top of RDMA, it's usually about a connected mode operation. So RDMA today is essentially implemented as a series of point-to-point messages being passed between instances. So there's a scalability question associated with that. We had a really great conversation with a guy from Los Alamos a couple of months ago, and he rattled off in the space of an hour about 15 gigantic issues related to the scalability of MPI over RDMA. And I just captured a few of them here because, candidly, I wasn't quite smart enough to understand all of what he said, but it was really great stuff. And I'm hoping that we have more time to spend asking that exact same question of others who are using these large-scale systems. Well, one of them was the scalability of reliable connected mode. So every time you create a connection in RC mode, you consume some resources. You consume some queue pairs. You consume some memory space to support the queue pairs. So there's a pretty prodigious consumption of resources associated with reliable connected mode. There are some issues that were raised with respect to RDMA CM, for example, its scalability and its overhead. You have to, sort of create connections, each one of these, and that's a time-consuming activity all unto itself. And there are questions about how well it scales And at what point does the number of cores or processors per node exceed the ability to realistically connect them using RDMA-CM? So that was an issue for him. Addressing scalability is one that we talk about all the time. Is the lid space big enough? Don't know. Probably not. It needs to be made bigger. Resources per queue pair. This is the memory footprint question. Every time you create a queue pair or a connection, you allocate some memory associated with it. And the question is, are there more efficient ways to do that? Memory registration overhead, there's processes involved with registering memory. You guys know much more about that than I. Code bloat came up as a question due to the support for multiple MPIs. And the suggestion that was made, well, maybe if we partition the MPI problem into a generic part and a network-specific part, we can reduce some of that code bloat. I don't know. I'm just saying that there are some opportunities here for us to look at improving the scalability of MPI applications. Okay, so broadening support. So there's some things we can do in MPI, but what about shared memory? So I don't think we've ever really spent an awful lot of time talking in a lot of detail about shared memory for distributed computing. And I say that knowing that there have been some really great sessions presented in this room and at Sonoma on this very subject of PGAS. But it seems to be gathering even more currency for some reason. And if that's really true, then we in the OFA probably owe it to ourselves to really get engaged and drive that forward in a meaningful way. So the shared memory programming model, my sort of simple view, each execution instance creates a single channel to the virtual shared memory. So right away, you may have overcome at least some of the scalability problems associated with creating lots and lots of connections. So let's see, shared memory systems are desirable because they're scalability characteristics. Bill, you're telling me 10 minutes, but I think I have till 9:30. Yeah? I get my time. I'm going to take all of it. I'm telling you. You're going to have to drag me off here. That's right. So message passing versus shared memory. There are endless debates over this. One, the value of one versus the other. There's partisan camps on both sides and tons of white papers about this and scholarly research papers of which I've read almost none. Anyway, but there are some who say that you can implement shared memory over a message passing architecture, and it's true, you can. And there are some who say the inverse, you can implement message passing using a shared memory architecture, and it's true, you can. But I don't think the question that we in the Open Fabrics Alliance want to ask is, which do we throw our lot in with message passing or shared memory? The answer is both, obviously, because we have people who would like to use Open Fabric software who see value in both of them. So rather than debate the merits of message passing versus shared memory, maybe we should instead spend some time asking ourselves about where does a message passing architecture make sense and how can it be improved? So what can we do to RDMA today to make it do a better job with scalability and MPI? And should the OFS improve its support for shared memory? So we do have support for PGAS or PGAS languages built into the Open Fabrics Alliance today, but how efficient it is remains to be discussed. So expanding the taxonomy some more. So again, I put these things in these 4 large buckets. And we talked about usages a little bit, and that was mostly about data analysis and data storage and data access, although there are other characteristics or other buckets that include usage models besides those 2. I just gave those as examples. And I just hit on a little bit of scalability as reflected by the bucket of distributed computing. But again, scalability really crosses the gamut here. There's scalability issues related to, for example, data storage. The amount of data under storage is getting huge, which implies scalability issues there. But we've hit both scalability and usage. We haven't talked about technology. We'll get to that in a minute. So anyway, the question that I keep coming back and asking is the characteristics of each of these classes of applications really says a lot about what the underlying I/O infrastructure really needs to be. And again, in the case of the distributed computing one, message passing versus shared memory, it's pretty stark what the underlying characteristics of the I/O infrastructure would be to support message passing versus to support shared memory. So today it's about the verbs, But really the question ought to be asked, can the verbs interface be improved in some meaningful way? And are there classes of apps for which verbs may not be the right interface? And yes, we already have things like PSM and MXM. So again, I'm trying to use this top level, the application level, to sort of help us derive the requirements of what the underlying interfaces ought to be. And from there, knowing something about what the underlying interfaces look like that the applications would like to see, what does that mean about the network beneath it? What kind of features or characteristics or protocols need to be supported by the underlying network in order to properly support these classes of applications through whatever their chosen interface happens to be. All right, so we hit scalability and we talked about usages. What about technology? I promised I'd get there. So a few examples of the march of technology, moving forward. Solid state memory, I mentioned it before, has the potential to remake the way that processors store and access data. There could be a movement in changing an entire revolution, so to speak, in the memory hierarchy afoot as a result of non-volatile memory. And I've got a couple pictures. I'll talk about that for just a minute. Multi-core processing may change the way that threads are allocated to cores, and thus may change the basic demands placed on the interconnect. It's obvious if you think about it. Again, my role here today is just to say things that are obvious so we can think about them. Heterogeneous processing may change the profile of the traffic passing between cores. You're going to pass different qualities of messages back and forth between a GPU than you would if it were all implemented in pure x86. So here's the memory hierarchy one. I'm kind of fascinated by this one these days, and I think it's going to be something we're going to spend some time dealing with over the next several years. But classical open fabric software stack assumes the existence of what I would call a traditional memory hierarchy, which begins with processor registers at the top, a caching layer, main memory, volatile main memory, then some sort of a file system, and then beneath that, rotating media, and then a gradation of storage beneath that, and some nearline and offline below that. That's sort of a classical, abstract view of a memory hierarchy. I think most people in the room would not argue strenuously with that. That's sort of the baseline of where we have been, where we more or less are today. And in that classical memory hierarchy, at least from an I/O perspective, there's data that could be buffered, let's say here in the file system or maybe in disk caches at the rotating media itself. And the cost of the memory used to do that so far, up until the not very distant past, has really been on a rough par with the cost of main memory itself. And that said something about who wants to cache how much data where in the memory hierarchy, because you're constrained by the costs of memory going forward. But with the advent of low-cost non-volatile memory, that may change. It may actually force a refactoring, so to speak, of the memory hierarchy itself. So I stuck in a couple of white boxes there labeled non-volatile memory. So where there's a lot of discussion going on right now, for example, about burst buffers as a way of buffering data coming off a file system. And that leads to questions about where do you put the burst buffer? Do you put it in front of the network? Do you put it behind the network? Do you put it somewhere further down the stack? So there's this potential refactoring of the I/O hierarchy that's going on as a result of the introduction of non-volatile memory. This is something that we, as Open Fabric software, need to pay attention to. And in fact, there's some sessions coming up later in the workshop on this very topic for that reason. I could even venture to guess that it may lead to a change in the kinds of I/O protocols that we use, and hence the way that we transport those protocols over the network, which is what we in Open Fabrics Alliance do. All right, so I'm getting to the end here. Bill, you guys happy now? We're getting close. So challenges ahead. Again, I just sketched a few out. My role is not to be, comprehensive, but just to throw some thoughts out there and as food for thought to get all our brains wrapped around these ideas. But scalability, what programming models do we want to support? What about message passing? What about shared memory? What about other programming models? So those things that we should be looking at as an alliance. And the inherent network scalability itself, the lid spaces, the number of queue pairs, connected mode, all of those things. Next was the technology. So how is that going to impact the way that we look look at I/O going forward. So SSDs, for example, multi-core and heterogeneous processing. I touched on all those just as examples. And third, the place I started, usage models. So, there's this big data, this notion of big data. Does that imply a change in the way that we do I/O? I don't know. I think it probably does, but I don't know. Cloud, again, same question. Does it imply a difference in the way that we look at I/O? And my favorite, storage at a distance, where I'm trying really hard to get that in everyone's mind these days. How do you access large data sets over long distances, either by copying the data or not? Maybe you're trying to do data access with data at rest and avoid that copy. So this is the storage at a distance topic. And I sort of categorize that as good collaboration amongst distributed teams. Okay, so here's the sort of a canonical, again, abstracted version of the Open Fabrics architecture. So there's the application layer, there's the interface layer, and then there's the provider and hardware layers. And the point behind this slide is that it's all fair game. These are the things that we should be talking about in this room over the next couple of days. So what applications or classes of applications do we need to support? Are there ones that are not on the list today, that there are not ULPs for that there should be? For the ones that there are ULPs for, are we doing a good job of supporting them, or are there things that we should do to improve them? For example, MPI support, can we do better? PGAS support, can we do better? So the ULP layer, that's an area for fair game for us. And the next one is the provider layer and the hardware layer. And again, I went to lengths earlier on to say that those two layers are driven by the specifications that drive these networks themselves. We don't control any of those specifications, but we can, I think, influence them. So if what comes out of this is, InfiniBand, you're doing really great things, but it would be really nice if we had this, or this, we can take that to the InfiniBand Trade Association and ask it to look at, do we want to improve the specification going forward? So this is all fair game for us. Don't be thinking, well, we're just the network stack and that's what we do. That's not the case. We can drive the I/O industry going forward. Arguably, we in this room have the very best view of what I/O looks like going forward. So here's this table again. I just wanted to put it back in front of you, and it's just my way of trying to capture that discussion. There may be a different or better way to do it than this table, but we'll start with this and see how far it gets us. I think we're going to try to put a copy of it up on a flip chart somewhere in the course of the next day or so, and hopefully people will feel inspired and run up and grab a marker and say, you should put this under scalability, and we need to address that, and then we can ask ourselves, how do we address it, and of whom do we address it? So here's my, required call to action slide. During the course of the next couple of days, there are going to be sessions devoted to each of these topics. I know that because that's how the workshop was organized for a very specific reason. So what we want to do is to be thinking about the impacts of the I/O on both the I/O software stack and on the underlying network of everything that you hear over the next couple of days. So be asking yourselves, what does that mean in terms of the OFS software stack? What do we need to change or modify or add? What does that mean in terms of the implications on the underlying network? So think about improving the verbs model and ask, where does RDMA make sense? And or do we want to expand RDMA? And or are there areas where RDMA may not make particularly good sense? We should be open to that possibility as well. Not making any statements either way. I'm an RDMA partisan. I've worked with it for years. I think it's great technology. Doesn't mean it's the answer to everything. Just because we got a hammer, not everything's a no. So on Wednesday, we're going to get together and we're going to try to integrate all of this and plot a course going forward for ourselves and hopefully extract from that some guidance that we can take to the standards bodies to help them drag them forward into the future as well. So that's what I have to say, and I guess we'll see you all on Wednesday. So, questions? Hopefully not, because I'm so bleary that if you ask me a question, I probably will give you the wrong answer. Christoph.
Over the last few days, I've always been shocked by some of these presentations because the major element is missing there. You have IB there, Rocky, but you don't have Ethernet there. We are using the RDMA APIs with Ethernet and to a large extent, and this is one of the major use cases in our company.
So I don't disagree at all with what you're saying. In my own defense, what I'm going to say is there's a provider layer and a hardware layer. And if what comes out of this is we better do this all over Ethernet and not call it iWarp, you bring a very good point. By all means, let's do that.
But Well, we do real Ethernet, which means we can create real Ethernet frames via the RDMA APIs. This is not something encapsulation that IWAP or Rocky or IB would imply.
That's exactly right.
So, yeah.
You're already thinking exactly where I was hoping we'd be. Thank you.
So what is the interface to that? You don't use verbs then, right?
Yes, I do use verbs.
Okay, so...
But you may or may not use verbs. I can imagine a case where it's not the right interface. Probably is. We could probably make it work. Maybe it is the right one. I don't know. We should talk about it.
I think you're advocating we continue using verbs.
Of course, we are using verbs to create Ethernet.
Which is a good,
Which is what he said.
which is a good conversation right there all by itself.
He said that's at the hardware layer.
Yeah. I just want to comment on this subject that we should treat verbs maybe as the common SDK for user space access. So in case of raw Ethernet, basically it's the means of exposing queues to user space. So the queues could be Rocky transport, IB transport, or raw Ethernet transport. And in any case, this is verbs. And we can, let's say, add additional functionality to these verbs that accommodate such needs as as Ethernet. For example, RSS support at user space, TSO, like transmission segmentation offload, and all these nice features that we have like in Ethernet drivers, we can expose them through verbs as a generic SDK, so user space stuff can take advantage of them just as well.
And over the course of the next 2 days, not right here, we should have that exact discussion. Do we want to continue to expose things through verbs, or are there places where we really do need a different interface? Maybe yes, maybe no. I'm a verbs partisan. I believe in verbs as a description of the semantic behavior of the underlying network. But if what's being implied in terms of the requirements in the network by the applications we're supporting is different than the semantic behavior we have today, either we have to change the verbs or we have to look at a different semantic description. And we should be open to asking that question.
So I agree with a lot of what you said in here. Being an MPI developer, having a history of being an MPI developer, there's a long history of MPI developers coming to this forum and not being received well. So it's nice to see a talk where we're proposing something. The difficulty, I think, you see instantly in the comments, right? That we as upper layer protocol developers have always felt. You give a great talk about upper layer protocols and how we need to think about them, and instantly we dive to the lowest layer in the transport. And so, to the developers in the room, I really challenge you to think about this in terms of, what are the pain points that the application layer is feeling, particularly that right box, the distributed computing, because there's a lot of pain points there that are going to become more and more severe in the next year or two.
And to that point, and this is a very good point, I'm glad you brought it up, but a plug for Susan and the work she's been doing with the users. That's what this is all about. Users Day is about people who are trying to use this stuff to do something real. And if we don't really clearly hear what the users are saying, we're going to be hard-pressed to figure out how we evolve going forward to meet their needs. And that was, I would say, a big part of the motivation behind the formation of the Users Day in the first place. Was, we got a whole bunch of developers here who are developing code. There's no users in this room, or at least not many. But yes, thank you, good point.
One additional thing, the vision that we have of the RDMA APIs is an access layer for the low-level hardware that bypasses the OS, and that's the key point here. And I think also the recent support by Intel for the Xeon Phi illustrates the same issue. They also have used the RDMA APIs to expose low-level access to the coprocessor. And so that is a very important role in terms of the Linux kernel, because basically the maintainers of the traditional network stack have rejected offload technology. And so the RDMA APIs take on the role of the offload technology in the Linux stack.
Yeah. And I often try to make the distinction, at least in my own mind, between RDMA as a framework or a communications model and the implementation of RDMA, which is InfiniBand today. So InfiniBand defines a whole bunch of mechanisms designed to move messages between memory spaces, but it's the movement of messages between memory spaces that really counts. How do you do that without involving the OS? So there's a distinction in my mind between RDMA and the verbs that specify the semantic behavior of RDMA and its implementation in InfiniBand or Rocky or iWork today. Sort of a subtle distinction, but sometimes important. Anything else? If not, I'd love to get off this stage. Now I want to. I've said my part, let me go. Thank you.
Thank you very much, Paul.